Hello everyone and welcome back. My name is Mr. Cobalt and in this video I'm going to be going over kinetic energy and heat. So let's get into this. So an object's kinetic energy can be classified as either internal kinetic energy or external kinetic energy. So when we talk about external kinetic energy, that's what we were talking about in my earlier video when we're talking about the falling object. So if I flip a coin, the coin as a whole has a certain kinetic energy to it. The coin as a whole is moving at a certain speed, it has a certain mass. And so when I talk about the kinetic energy of the coin, I'm referring to what is also referred to as the external kinetic energy. That means the energy, the kinetic energy that's related to the object's overall mass and to its velocity. So the falling coin is an example of that external kinetic energy. The internal kinetic energy is the energy that's associated with the internal motion of the particles that the object is composed of. So if we look here at my picture of the coin, here the whole coin is falling to the ground. So this coin has a certain mass to it. It has a certain velocity. So I can use my 1/2 equals mv squared and I can calculate the external kinetic energy of the coin as a whole. But then this coin is also made up of particles, atoms, that are also in motion, right? So I can zoom in and look at the internal motions of the particles that make up the coin, and I can see that they're moving at different speeds and different directions. They're vibrating with each other. So they're vibrating in different directions and with different frequencies and different amounts of energy and things like that. So I can look at all of these, and that would be the internal kinetic energy of the object. So in this video, I want to focus on the internal kinetic energy and heat. So now that I've kind of explained what we refer to as the internal kinetic energy, um, we need to know that the amount of internal kinetic energy of an object can be increased in three general ways. So one of the things we got to remember is that there's a relationship between, say, the temperature of an object and its internal kinetic energy. And so that's written up here. So the temperature of an object is proportional to the average internal kinetic energy. So if the temperature of the object increases, then the average internal kinetic energy of the object increases as well. So that means the average velocities of the particles is increasing. So temperature is related to the motion or speed or the average speed and motion of the particles in the object itself. So that's why it's related to the internal kinetic energy. So the internal kinetic energy is related to the motions or movements of the particles in the object, and that again is going to be related to the temperature of the object as two. Faster moving particles in the object is going to be proportional to higher temperatures. Slower moving particles in the object is going to be related to smaller. Sorry about that. So as I was saying, the faster moving particles of the object is going to be related to higher temperatures, and slower moving particles is going to be related to lower temperatures. Okay, so when we talk about the amount of internal kinetic energy of an object being increased, there's three general ways in which you can increase the kinetic energy or the internal kinetic energy of the object, meaning that the particles are going to be moving faster. They're going to have more motion. So how do you do that? One way is to rub, compress, or distort the object. So, for example, it's cold out. You come inside from the winter, and what do? You rub your hands together. The rubbing of the hands together will create heat. Why? Because there's friction. You're rubbing your hands together is causing friction, and that's creating that's causing the particles in your hand, the molecules, the atoms, to move faster, and that's creating more heat. Okay. Two, or another example of number one is if I take a hammer to a piece of metal, if I start hitting the metal with a sledgehammer with a hammer in the hand, if I keep hitting it, if I touch the metal after hitting it, you'll notice it gets warm. So in the process of hitting, I'm transferring energy to the particles in the metal, and so the particles then move faster, and they're going to increase the temperature. So it's going to have increased heat, if you will. A second way of increasing the internal kinetic energy is by putting it into contact with another object that is at a higher temperature. So what happens when you put two objects together that one is a lower temperature and one is a higher temperature? Well, when you put them together, the the particles in the hotter object, right? So let's say this is the hotter object. The particles in this object are then going to be in contact with the particles of the colder object. So the hotter object, those particles are going to be moving faster. So they're going to be colliding and bumping up against the particles on the surface of the colder object. So they're going to be transferring their energy to the slower moving particles. The slower moving particles are then going to move faster, thus raising the temperature of the colder object. But then the particles in the hotter object down here, those are going to lose energy and therefore move slower and then have a lower temperature. So the hotter object will cool down while the colder object will kind of heat up until there's equal temperature. And I'll draw a picture of that in just a little bit later in this video. Okay, so that's one way. So the third way is then to expose the object to radiant energy. For example, you let it sit out in the sun for a long time. So if you let it sit out in the sun, it's going to pick up the radiant energy. That's going to cause the molecules and the particles in the object to move faster because they're absorbing that energy, and that energy is going to cause the internal kinetic energy to increase, and therefore the temperature's increasing as well. Okay, and one more thing before I move on to the contact, talking about this a little bit more regarding the contact of one object with another, I want to talk about heat. So we need to define what heat is. So when we talk about heat, what we mean is that an energy that is transferred. So heat is energy that is transferred from a region of higher temperature to a region of lower temperature as a consequence of collisions of particles. So that's what I was talking about before with the hot object in contact with the cold object. So the particles at the surfaces are in contact with each other. So the transfer of energy from the hotter object to the colder object, that heat or that that energy that's being transferred, we refer to as heat. So heat is being transferred from the hot object to the cold object. And so I'll draw a picture of that in just a moment. So just stay tuned. Okay, so let's get into that second part of how to increase the internal kinetic energy of an object. So that was by putting one object into contact with another object that has a higher temperature. So here I have a picture of the surfaces of two objects. So here I have the colder object in blue. the hotter object in red. And here is where the surfaces are in contact. So I want to point out in the picture that you can see here that there's these little lines here. There's two lines representing how fast or how much they're vibrating. And here for the hot one, you can see that they're vibrating more. I drew 3 here for each one. Here I have 2. So that's supposed to kind of give you the impression of how fast or how much the atoms are vibrating at the surface. Now, they're vibrating throughout the whole substance, but I didn't want to draw it because it's just too much for me to draw. But just know that the hotter object has more internal kinetic energy because the particles are moving faster, and so they're going to be higher temperature. And then the colder object, the particles are not vibrating as much, they're vibrating slower, and so they're coming into contact with each other. So here, what's going on? So as I said, the particles at the surface are in contact with each other, so there's going to be collisions here. So here there's collisions between the particles, but they're transferring heat between each other. So the overall average kinetic energy of this object doesn't really change because they're just transferring the energy between each other, and it stays within the object itself. But then the same thing goes with the colder object as well. So they're colliding with each other, transferring energy or heat between the particles. But again, the average doesn't change for the object as a whole. But when they come into contact with each other, the surface particles of the hotter object are going to collide up against the surface particles of the colder object. And so what happens is that the lower temperature object is going to have a lower average force of collision, right? So they're going to collide with the hotter object that has a higher average force of collision. So what happens is that when they collide, some of the energy of the hotter or faster moving particles is going to be transferred to the slower moving particles, thus causing the slower moving particles to vibrate faster. And therefore, the particles in the hotter object are going to move slower because they transferred some of their energy. So that means that these are going to have an increased amount of speed, and then these are going to end up having a lesser, slower, a decreased amount of speed. And therefore, again, remember the average speed or internal kinetic energy of the molecules is related to temperature. So then, as these particles are colliding with these particles at the surface, then the energy is going to be transferred this way. So if I write this down, energy or heat, right? Heat is going to be transferred this way from the hotter object, right? Hotter object to the colder object. Until, of course, they reach an equal temperature, which means that the average kinetic energy of both objects are equal. And so that's what I have written here. So lower temperature object has a lower average force of collisions. Then the particles are going to speed up in this object when they collide with the particles of the higher temperature object. And then they're going to increase their energy. Therefore, their internal kinetic energy is going to be raised and the temperature is going to be raised. The higher temperature object has higher average force of collisions in their particles. So they're going to transfer energy to the colder object. So the particles will slow down when they collide with particles of the lower temperature. And then they're going to have decreased energy, which is going to be decreased temperature. And of course, until the temperatures are equal, and then both objects have the same average internal kinetic energy. And so that's it for this video. If you like this video, if this was helpful in any way in helping you understand kinetic energy and heat, then please by all means like the video, share the video with your friends, hit that like button. Also, don't forget to subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos that I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Let me know what videos you would like me to do. I would like to do that for you. Thanks for joining me and have a great day.